Hey Finxters, what's up? It's Chris, founder of Finxter.com, and in today's video I will finally wrap up the all my video courses about the Python operators, and will give you a short overview about the precedence relationship. So what is operator precedence? So we have, for example, if you have this arithmetic computation, mathematical computation, 2 plus 2 times 0, then what is the output of what is the result of this operation? So it is not 2 plus 2 is 4 times 0 is 0, so the result is not 0 of this operation, right? The result is 2. Why is that? Because the asterisk operator takes precedence over the plus operator, right? So this is like most people know this, and it's the same for all Python operators. So there is a precedence relationship of all Python operators, so you know exactly which operator takes precedence over which other operator. And I will quickly go through the list, and then we will dive into some examples. So let's go over the list of operators. So the parenthesis has the highest precedence, so this will always, first of all, we will always consider the parenthesis, and if there is a parenthesis, we will first compute everything within the parenthesis before we actually compute things outside of the parenthesis, right? So parenthesis has the highest precedence relationship, and you can explicitly override this precedence relationship by for example, giving the parenthesis like this. Okay, so in this case it will be 0 in fact, because now we will first compute 2 plus 2 and then we will multiply it with 0. Okay, the second one, second topmost precedence operator is the exponentiation operator. Then you have bitwise not. Then you have the multiplication, division, modulo, integer division operators have the same precedence level, right? So multiplication and division and modulo and integer division all have the same precedence level. So for example, if you have so we will see an example. Let me quickly go over the list. I will dive into an example next. Okay. Then we have addition and subtraction. Subtraction, they have the same precedence level. Then we have bitwise shift right and shift left. And I have made a video for all of those, so you should already know about those operators. Then we have bitwise AND, which takes precedence over bitwise XOR and OR, which are in the same level. Then we have the comparison operators, like smaller than equal, smaller than, larger than equal, and equality or testing for equality or inequality. Then we have the in place assignment operator. So we have the equal symbol, modulo, equal. So basically these are these operators actually have pretty low precedence. So first we will compute everything else before we actually assign the result to the operator. Then with pretty low precedence as well are the identity operators. So we have is not, in, and not in. And finally we have the logical operators like not and or. So this is the basic precedence relationship, and you should know that for operators that are in the same cell, in the same level. So for example, let's take those 4 operators. If they are in the same level, then the precedence relationship is resolved from left to right. And so an example is, say we have 2 times 3 integer division 2, right? So this is a good example. So now we know from the table that multiplication and integer division are in the same precedence level, right? So we have those 2 operators have the same precedence. So which one do we compute first? If you would compute 3 integer division 2 first, the result is 1, right? Because we divide without remainder and we round to the next integer. So we have we basically round down to the next integer. So we have 3 integer division 2, which is 1. So now we calculate 2 times 1, which is 2, right? So if we would calculate this one first, the result would be 2. But if you calculate this one first, we have 6, and 6 integer division 2 is 3. So we have so if you compute the multiplication first, we obtain 3. If we calculate the integer division, first we obtain 2. So therefore it really matters, the precedence matters. So let's see what happens. 3, right? So we first compute the left operand. So we basically, Python parses this expression from left to right. So boom, boom, boom. It sees, okay, this one is the first operator with the same precedence level. So basically it first checks all the operators, and then it sees, okay, they are at the same precedence level. So now it resolves it left to right. So it first computes the multiplication, and then it computes integer division, right? Good. So what happens if you have, say, 2 to the power of 3 times 3? Then, of course, it would not calculate 2 to the power of 9, but it would first calculate 2 to the power of 3, which is 8, and then it computes times 3, so we have 24 as a result. Good. So let's maybe have, what if we have 2 times 3 is 6? This is a good example. Now is 3. Let's make this example. I will get rid of this. So if you have 2 times 3 is 3, then if is had the higher precedence, we would first see, okay, 3 is 3, which is true, and then we would multiply 2 times true, and true is represented with integer 1, so we have 2 times 1, which is 2. But the result is not 2, the result is false. Why is that? Because 3 is it does not take precedence. So we first calculate 2 times 3, which is 6, and now we check 6 is 3, and the result is false, obviously, because 6 is not 3. So what if we have 2 in 1, 2 is 1, 2? This is a similar example because in and is have the same precedence level, so therefore we will resolve from left to right. So we first compute 2 in 1, 2, 1, 2, and this is true, and then we check true is 1, 2, which is false, right? The Boolean value is not the same object as the list, so therefore the result should be false, right? And if say we would first calculate this operation, 1, 2 is 1, 2, and this is true. This is false. This is false. Sorry, because it's not the same list. This is false, and now 2 in false, it doesn't make sense, right? So for example, if you this one would simply raise an error. Now I need to close it. Okay. So because here we have a Boolean value, now we want to check if 2 is in a Boolean value, and the Boolean value is not iterable, so therefore it raises an exception, right? So this is important. You see the semantics change with the precedence level. So if we need to know the operator precedence level, and you can try it out, and over time you will get a good feeling of it. But I think it makes sense to having watched this video about the precedence level. Okay, so now let's check the Python precedence of logical operators. Basically, not takes precedence over and takes precedence over or. So I should have said this in the beginning, but yeah, they are actually not the same level. So you see an example here, not false and false. So now you could basically you check for if you had, if you would compute this one first, then of course you have true and false, so the result is false. But if you would compute this one first, false and false, the result would be false. You would invert it to true, so you would get true as a result. But this is not the case, right? So therefore we know that not operator takes precedence over the and operator. And yeah, then we have, let's check another rule. So if you have the following, true or false and false, and now what happens here? Actually, if they both would have the same precedence, if and or would have the same precedence, we would resolve from left to right. So we would first compute this operation, true or false, which is true, because at least one operand is true. So we would obtain true and false, and true and false is false, right? Because not both operands are true in an and relationship, so therefore we would obtain false. But if we run the code, we obtain true. So why is that? Because and takes precedence over OR. So we have false and false, and this is false obviously. And so we have as a like final result of not final, the next step result would be to calculate true or false, the output of our AND operation. True or false is true, so therefore the result is true as well. So you see, it really makes sense to study those deeply. So what about associativity? Associativity defines the order in which an expression with multiple operands of the same precedence level are evaluated. For example, multiplication and integer division have the same precedence level, and Python resolves it by going from left to right. We have already seen this in our previous example here, and we have seen it in this example. Okay, so I think that's enough for today. You can also check out like the precedence chart on the blog post if you're interested. I have actually prepared a precedence chart. It's now very small and on an article video. So here you see like we have parentheses is the topmost, and the lambda expression is the bottom precedence operator. Okay, anyways, thanks for listening to this full course. I appreciate you taking the time, and I hope you have learned a lot about Python operators. These are the basics, and understanding the basics is very, very important in Python, because it will be relevant for each and every code snippet you create. And this means that the return on your invested time will be huge, right? So if you say improve your speed or understanding by 5%, you will either code 5% faster, or you will have 5% fewer bugs by going through all Python operators. And of course, I mean, this will just add up significantly. So if you have the average coder salary is 100,000 bucks per year, and you improve it by 5%, which means 5,000 bucks per year, just by listening so your productivity rises by 5% each year. So which means that just by listening to a video course taking a couple of hours to finish, like that you could theoretically finish in one day, you actually have increased your value to the marketplace as a coder by 5,000 bucks every year at least. Okay, anyways, thanks for listening to this to this full course, and see you in upcoming courses. Bye.